Here we go. I'm going to demonstrate a multiplication of fraction problems. That's in our 6th grade standards. 6th graders are expected to know how to do a problem like this. When I look at 9/10 times 5/10, there's some ways I could simplify that and give myself an easier problem. But what I'm going to do is pretend that I'm a person who really struggles with mathematics and I don't see the ways to simplify. So the first thing I want to do in a problem like this is, let me do that here and let me grab a different color, is doing a 9 times 5 to get 45. Okay, and then 10 times 10 is how much? Right, it's 100. Now I have to simplify this. I can take a 5 out of both numbers. With 100, you might think of that as just 10. How many times does 5 go into 10? The answer to that is pretty simple. 5 will go into 10 2 times. So if 5 goes into 10 2 times, 5 goes into 100 20 times. So my new bottom number is 20. And then 45 divided by 5 is 9. Remember, let me just kind of make that a little more visual, is what I did was my common denominator was, my common factor was 5, and I just divided both those numbers by 5 to get 9/20. Now, before I go on, a word about simplifying. Some of you probably realize that I could simplify 5/10 to 1/2. And that's perfectly legitimate. If I would have done that, I would have just given myself an easier problem, which would have been 9/10 times 1/2. Another way I could have given myself a simpler problem is by cross-canceling. I could have crossed out this 5, because 5 will go into 5 and 5 will also go into 10. And I could have changed one number in both my fractions. 5 divided by 5 is 1. 10 divided by 5 is 2, right? 9/20. So you would still have arrived at the same answer. You just want to look out for things like that, how to simplify a problem. Let's take a look at our next multiplication problem. Again, I'm going to just assume that I don't know how to cross-cancel or give myself an easier problem. So many 6th graders, if they couldn't see how to do this, they'd simply take the numerator times the numerator. 8 times 3 is 24. 9 times 4 is 36. And now you got to find a number that you can take out of both of those. All right. I can actually take a 12 out of both of those, but most people probably wouldn't be able to spot that. They'd say, oh, I know that 6 goes into both of these numbers. So I can simplify by first dividing by 6. 24 divided by 6 is 4. 36 divided by 6 is 6. Need to keep going. I'm going to divide both these numbers by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And I can't go any lower than that. That is my second answer. We're going to take a look at a little bit more complex multiplication problem now. Here we go. We have 3 3/8 times 2 1/3. I could do some distributive property, but usually what most people do with this is they're going to keep it a multiplication problem, but instead of multiplying mixed numbers, they're going to multiply 2 improper fractions. So the first thing that we're going to do is turn our 3 3/8 and 2 1/3 into improper fractions. Well, here's how I do this. I take 3 times 8 to get 24. 24 plus 3 more is 27. So my first number becomes 27/8. The bottom number does not change. Do the same process with the second fraction. 2 times 3 is 6. 6 plus 1 more is 7. 7 becomes your new top number. 3 remains your bottom number. Okay, now I demonstrated cross-canceling before. 3 and 27 share a common factor. That common factor is 3. 3 divided by 3 is 1. And 27 divided by 3 is 9. All right, so now let's do our next step. 9 times 7 is 63. 8 times 1 is 8. Our problem now becomes 63 divided by 8. So what does that look like? We have 63 going in our division box. 8 is on the outside of the division box. How many times will 8 go into 63? That's 7 for those of you playing at home. 7 times 8 is 56. All right, we borrow. 13 minus 6 is 7. 8 doesn't go into 7. So now I got to put these numbers together. And there's a way that I do that. My whole number becomes this. So I have 7. The denominator of my fraction is the number I was dividing by is 8. And my leftover piece is 7. So the answer to this problem is 7 and 7/8. Here we go with the second multiplying mixed numbers problem. And remember what we did in the first one. We didn't leave them as mixed numbers. We turned them into improper fractions. So if you can kind of think about the steps for that. First, I'm going to do 1 times 6 is 6. 6 plus 2 more is going to get me 8. So my first fraction is going to turn into 8/6 after I do all my multiplication and addition. To turn my second fraction, I'm going to do 2 times 5 to get 10. 10 plus 4 is 14. So my new top number is 14. 14/5. Now, earlier I demonstrated some cross-canceling. Again, I'm going to do some cross-canceling in this because I do want to give myself easier problems. I'm crossing out the 6 and the 14 because I can take the number 2 out of both of those. 14 divided by 2 is 7, and 6 divided by 2 is 3. All right, so now we're ready to take 8 times 7, and when we take 8 times 7, we get 56. And 3 times 5 is 15. Our problem is 56/15, or 56 divided by 15. We can't leave it like that. So we're going to put 56 in our box because we're dividing by 15. 15 goes on the outside. You'd have to do some estimating here. Some people might try 2, they might try 3, they might try 4. What they're going to find is this is only going to go 3 times. 3 times 15 is 45. So now we do our subtracting. 6 minus 5 is 1. 5 minus 4 is 1. All right, now let's put everything together. So we start with our whole number. There's our whole number, 3. We are dividing by 15, so that goes on the bottom. My leftover piece is 11, so that goes on the top of my fraction bar. Numerator is 11, denominator is 15. My answer to this problem is 3 and 11/15. Now that we've looked at a couple of multiplication problems, it's time to go on to dividing fractions. The first rule of dividing fractions is that, hey, we don't divide fractions. We turn them into multiplication problems. So you might ask yourself, oh, how on earth do we do that? It's really not that difficult. We take the first fraction, 2/4, we leave it alone. So we just recopy it over. Our division sign becomes a multiplication sign. And then where our real change comes is with this second fraction. We're going to use, the term is called reciprocal. And that just means we take the denominator and we make it the numerator. And we take the numerator and we make it the denominator. Okay? Kind of stumbled with my words there, but that's okay. So that word is reciprocal. Sometimes to help kids remember it, we change that up a little bit and we call it refliprical, so that you're reminded, oh, flip the second fraction. All right? So now we're ready to do our multiplication. 2 times 5 is 10. And 4 times 3 is 12. Okay, there is a number that I can take out of both of these. I got to put it in lowest terms, or I got to simplify. And I can divide both of these numbers by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. And now I'm in lowest terms. I can't change this fraction any more than what I've done. So 5/6 is my answer. Those of you that are really good at seeing things might say, oh, I could have gave myself an easier problem right off the bat because 2/4 is really 1/2. And if I would change that to 1/2, I would have given myself an even easier problem to do. Let's take another look at division here in a sec. Here I have a second division problem. I have 8/12 divided by 1/6. Again, we don't divide fractions, we turn it into a multiplication problem. So in changing this one, my 8/12 stays the same. My division sign becomes multiplication. And then I use the reciprocal on the second fraction. When you hear reciprocal and can't remember what it is, think refliprical. So the denominator becomes the numerator, and the numerator becomes the denominator. Okay, I could simplify this one, I could cross cancel this one, but I'm just going to pretend that I'm not very good with my math facts. So I'm going to multiply through. 8 times 6 is 48, and 12 times 1 is 12. So I now have 48 divided by 12, and 12 is going to go into 48 evenly. It's going to go 4 times. So our answer is 4. Stand by for yet another type of division problem with fractions. Okay, now I have 1 3/4 divided by 3 2/3, and I have two complications here. The first is we don't divide fractions, we turn that into a multiplication problem. All right, just like with multiplying mixed numbers, what I'm going to do here is turn these into improper fractions. So with my first fraction, I do 1 times 4 is 4. 4 plus 3 more is 7. So this problem becomes 7/4. All right, let's do the second one. 3 times 3 is 9. 9 plus 2 more is 11. So just to show you what I now have 11 over 3. And remember, we use the reciprocal. So with the second fraction, the numerator is going to become the denominator, and the numerator is going to become the denominator. So I flip it. So I have 3/11. 7/4 times 3/11. All right, we can go ahead and multiply through. 7 times 3 is 21. And 4 times 11 is 44. And I can take a 2 out of the bottom number, but not the top number. I can take a 3 out of the top number and not the bottom number. I can take a 4 out of the bottom number, but not the top number. Guess what? This is already in lowest terms. We can't go any lower than that. So our answer is 21/44. I've now reached my final problem, and it's another division problem with mixed numbers. I have 1 4/5 divided by 2 2/5. And what we're going to start out with is changing these to improper fractions. Remember, we don't divide fractions. Instead, we multiply using the reciprocal. 1 times 5 is 5. 5 plus 4 more is 9. So my first fraction is 9/5. The second fraction, remember, we're going to flip. But first, we're going to change it to an improper fraction. 2 times 5 is 10. 10 plus 2 more is 12. So I have 12/5. I'm just going to show you that because remember, I haven't done the second step, which is to flip it. 5/12. All right. Now with this one, I am going to show you cross-canceling because we can give ourselves a lot easier problem. 5 divided by 5 is 1, so I can turn both these 5s into 1. And then I can take a 3 out of both 9 and 12. 9 divided by 3 is 3. 12 divided by 3 is 4. Okay, so now we're going to multiply 3 times 1. What's the answer to that? Is 3. And on the bottom, we're going to do 1 times 4. 1 times 4 is 4. Our answer to this problem is 3/4. You can watch this whole video again as many times as it takes to help you understand the process. I know I go through things fairly fast. That's the great thing about a video is you have the stop and pause and you have the rewind buttons.